Hello, I'm Julian Kocha. Can you hear me right? Good. I'm Julian Kocha with SCANOSS, and I'm here to talk to you about how are we disrupting the software composition analysis space with open source software and open data. I'll tell you what are we doing, how are we doing, and all the things we've learned so far in our journey. Open source software continues to grow in an exponential way. Over 90% of our software is open source today. And it expands exponentially because it grows in adoption with over 90% now, but it also grows by getting to new areas. Software is growing to areas, hardware platforms are being replaced by software platforms, and you can see companies and people here who work with companies who are switching from hardware to software. And the challenge for these companies is that the adoption of open source becomes involuntary, invisible. With the use of new package managers, the new AI-assisted coding tools, new development environments, the process of bringing open source, of integrating open source, becomes invisible, involuntary. And this is a challenge for companies because companies have to produce secure and compliant products. And you cannot really comply with or protect or secure what you cannot see. And if you're using AI-assisted tools, then it's even more challenging because there is a study here, and I have the citation in the bottom. Up to 2% of the code generated by AIs is either exactly similar or the same, verbatim copies, or strikingly similar to code that is written by someone else, released as open source, which is, of course, I mean, that's the actual input to the tool, so it is quite possible that the output will equal the input in some cases. And therefore, you need to have a software composition analysis tool that will detect these kind of things. Not just detecting your components that you're using, that's easy, but also files that maybe we're taking from GitHub or from some open source repository, or snippets taken from Stack Overflow or generated by an AI-assisted tool. For that, you need to use an SCA tool with this kind of capabilities. And what's interesting is that this kind of tooling existed for almost 25 years now as proprietary software. So every company helping companies detect their open source, do it with proprietary software. So the shoemaker's son always goes barefoot, as we say in English. In Spanish, we have a phrase which is equivalent, which I like it because it sounds like a threat from Danny Trejo or Antonio Banderas. En casa de herrero, cuchillo de palo. Sounds nice. And it actually means at the blacksmith's house, wooden knife, which is the same thing. Both phrases try to resemble the irony of someone doing something for a living and not using it for the own self-benefit. And that is the case with software composition analysis companies. So we are changing this. So far since the beginning, it's been a proprietary monopoly. And although software grew and open source grew a lot, and lots of other proprietary companies showed up. So that hasn't changed for 20-something years until we came up to disrupt this area. So we challenged the status quo by having an open source based business model. So now we've learned that it is feasible to disrupt this market with a business model like that. And we also learned that a business model based on open data is also possible, and that is actually what we do for a living. So a little bit about us. We disrupt by being open source and by selling access to this massive database. We offer a free service, a free API through a foundation, and we provide guaranteed throughput, guaranteed availability, and on-premise deployments of this knowledge base to paid customers. And therefore, since we are an API, we are a database, we are an API. We offer our services through an API. And therefore, by definition, we're built for integration, this shift-left approach in mind. It's not that you need to see, okay, how do I integrate this new tool? Well, no, this is actually built to be integrated. And we provide, of course, a solution that is suitable for AI-assisted coding. And in addition to detecting open source, the software composition analysis, we also provide open source intelligence. So let's say you already have a software bill of materials that you build with any tool, and you want to know the vulnerabilities or the copyright statements, or you want to know the cryptographic algorithms used by all these open source components. We can answer that questions for you. I need to jump the slides here because they're a little bit mixed. And this knowledge base, it's massive. The knowledge base is massive. We have downloaded, as you can imagine, every single open source component in the community, and it's hard to build it and it's hard to maintain it because every second there are many open source component versions published, and we keep all these things updated. So we're talking about 200, I think this is outdated, 227, yeah, it's 250 million already URLs that we downloaded, and that translates to over 100 billion files and 2 trillion lines of code. So this is astronomical numbers. The database is huge. And maintaining this knowledge base is difficult. I mean, we need a dedicated team of data scientists to cope with this and the update, because it's not just building it, it's maintaining it, and a team of curators, because not everything is something that you can mine or harvest automatically from the APIs. There are many things that require a human curation. And once you have all this data, providing a reliable service at scale is also difficult, and the hosting costs are expensive. So it is a challenge to maintain all this infrastructure. And yet, we provide this for free. So if I go back, I say that we are an open source company and that we provide data. So okay, the data is proprietary, yes, that is our IP, but we are on a journey to open data. We understand that data is also something that will have to be volunteer and published, because there's, we understood this since the very beginning. It's just that it takes adapting a business model. There's a company behind, salaries that we need to pay, so it takes time to adapt this, and we are on a journey to make it possible. And so far we have made some major steps. The first one was to provide this data as for free, as in free beer, and not us as a company, because it will be not very interesting, or people will question when are we going to shut it down and start charging for it. So we launched the foundation, which is another set of challenges. And in Spain it's very difficult to have a foundation. But we did this. We launched this foundation 2-3 years ago. And the foundation provides this API called OSS KB that allows you to use all our open source points to that API. And it's absolutely free and anonymous to use. You don't need to register, you don't need a username or an API key or anything like that. So with that, we built our platform, and then we gained adoption of our open source. And then we started making steps towards open data. And the first thing we did was we launched the Perl to CPE dataset, which is what connects the package URLs to CPEs as open data. This is CC0, you have it in GitHub, you have the URL there, and this is updated several times a day. So you can pull this dataset to find vulnerabilities in your open source components. And we make it, I mean, there's of course a small script that will allow you to automate that. There is an automatically built SQL-like database with all this information, but basically, if you go to the GitHub repo, you have this data set in plain text, so it's easy to maintain in Git. And then the next step this year, we launched the crypto algorithms data set as open data as well. This data set defines algorithm names and the ways to detect these algorithms, and some sample code that you can use to detect cryptographic algorithms in your code. And I'll talk about this now, cryptographic composition. It's important to know your cryptographic composition, because there are many use cases for this. In the beginning, it was just about ECCN, export control classification, This is trade compliance. You need to comply with export regulations when you export components or things running software with cryptography outside of the EU or outside of the US. But there are many other use cases, and I'll cover them. So the crypto algorithms open data set includes the list of algorithms with a name that we gave to them, the definitions on how to detect these algorithms, which is basically by keywords, by function names. And then it includes attributes to these algorithms, like the strength and if the bits and some other attributes, and some reference code that you can use to scan and basically leverage these definitions to detect cryptographic algorithms in your code. And all this is published as pretty much almost public domain, CC0, as public domain as we can make it in the EU. And you have there the name, crypto algorithms open dataset. We couldn't think of a more descriptive name to it. And you can find this repo in GitHub. Use cases, as I mentioned, first is trade compliance, license, it's a cryptographic classification. And then there is a security compliance, because now you have this crypto algorithm validation program by NIST, CAVP, that defines the recommended and approved list of algorithms. And of course, all this is for quantum readiness. You need to make sure that the products that you're going to launch in a few years are going to be quantum safe, basically. And also to standardize, because the same thing with license compliance. Why reinventing the wheel? Why every company is coming up with their list of algorithms, their names, and their classifications? Why don't we actually get this standardized? And that is actually what we're going after. So, what we have learned in this journey. First of all, this is not riding a nice road. You're paving the road as you're driving on it. So it's difficult. It's not pleasant. It's a lot of work. But you're paving the road for whoever comes next and will be able to enjoy it. And then shaking up the status quo is risky, but actually it leads to great results and to solve problems in the industry. And that is something that we understand very well. Then it's difficult to separate software from data. I mean, I've been telling you that we are actually charging for data. Our contracts with our customers are data subscription agreements, not software. We're not a software provider. All the software you need to consume the data that we provide, you download it from the public repos. So it's difficult for people to grasp this concept. And as we deal with large companies, it's always the problem of, okay, but how are you treating our data? I mean, we're not treating any data. We are not selling software. Our software is open source. So the way that you actually get the software into the company is by actually pulling it from the repos like you do with everything else. And it's kind of difficult for people to understand this difference between data and software. And then changing business models is not easy. I mean, this starting as we've always been open source from the beginning, and now we are going towards open data. So it requires adjusting a business model and changing that, which is not easy. Also, the adoption takes a lot of effort. It's not that you just make something open source and people will adopt it right away. It requires a lot of work, and it's difficult because, first of all, you're not always welcome. Sometimes you just touch upon someone else's interest and people don't like it and they will reject you and then they will just play against you. And then the other thing is you cannot really please everyone. You have to actually define a roadmap and move forward, and of course you want to listen to what people say, but not everyone, you're never going to be able to please everyone. And there are things that sometimes are good for one user or one company, but not very much useful to everybody else, and therefore you have to be wise at deciding what is it that you're going to get into your main development track. And then the other problem, which in this forum might be hard to believe, but not everybody really understands the benefit of open source and open data. You're not always dealing with open source developers. Sometimes you're dealing with decision makers who've been consuming proprietary tools for 20 years, and it's difficult for them to understand what is it that we get as a benefit. Well, the benefits are tremendous. Like, first of all, you're not tied up to any vendor lock-in mechanism, for example. You are, everything that you generate as your information is your information, period. When you sell proprietary software, you try to make it as difficult as possible for your customer to switch to the next tool. That's the nature of proprietary software. You don't have any of that. And then the fact of being open source and using open standards and open APIs and so on makes it so much easier for people trying to integrate and to automate compliance. It's a big difference. But again, decision makers not always see this as obvious advantages, and it goes along with a lot of education and a lot of telling the benefits and explaining. Is also effort from our side. Then making sustainable open source software is not easy either. I mean, it's a lot of work. And when you see it from, oh, this is nice, I'll download it using it. But there is a company behind this with a number of developers, and how do they keep and make it sustainable? It's a very big challenge. And then, of course, as I mentioned, creating is not just the open source software, it's this massive knowledge base, which is extremely, extremely expensive and difficult to do. And then the other one, of course, launching a foundation is not easy at all. Just launching it is not easy. In Spain, it's very, very difficult. We managed to get it done. But then, once you have it, how do you keep it? How do you make it interesting? And how do you keep it active? Is also a tremendous challenge. I skipped one slide, which is in my going back and forth, I wanted to talk about the ecosystem that we built around our tool. When you make something that is open source and is available to everyone, people will adopt it if you do things right. And we managed to get a number of users in the community. Again, we want SMEs and independent developers, integrators to actually get to use our technology. And we managed to do that. And a number of tools, open source tools that maybe you're familiar with, like Fossology or ORT or Fosslight. Fosslight is not very popular here, it's very popular in South Korea. These tools make detection of what is declared in some shape or form. They detect your dependencies, they detect your license headers and license files. And these tools now natively integrate with SCANOSS, which means that now, if you're familiar with Fossology, now Fossology can tell you the license of a file that doesn't have a license header. There's no license header, I run Monk or whatever the agent name is, and then there's no license, then I run the SCANOSS agent, and then I calculate the fingerprints and I send them to the API, and there's a license, there's open source here, so it's reported. So, and of course, there are also commercial tools making use of our knowledge base. I cannot mention some of them. Universities hosting mirrors of this free data set. Auditing firms working on the same knowledge base, and there's been even a court case in Italy a couple of years ago that used SCANOSS it was run by Array, and it's a small company against another small company, which would have been impossible if you have to pay the fees for a proprietary software composition analysis tool. So the case gathered the evidence using SCANOSS. So the important thing here is that now there is a standard way of doing this. By having a solution in open source, you actually make a de facto standard. So there is a standard way of scanning. If you scan now with Fossology, or with SCANOSS, or with ORT, or Fosslight, you get to the same results. If you use proprietary tool A and proprietary tool B, who have different data sets and different algorithms, you get to different results. But now there is a standard way of doing this. And because there is a standard way of doing this, for companies, it's critical to actually use this tool so that they get the same visibility as anyone in the community has, right? Otherwise, you're just using a proprietary tool, and then you might be missing something. Let alone the fact that we claim that we have the biggest knowledge base. We are the company that is, our focus is just making the biggest and most precise knowledge base. We don't sell software. But leaving that aside for a second, just being a different database and being a standard database makes everything else less interesting, and that is the benefit of open source adoption. So that's pretty much everything I had to say. Thank you all very much for your time and attention.